Hey everybody, welcome to Day 3 series with Spring Boot. We'll cover Spring Boot profiles and other topics in this video. As application grows, they typically need to run in multiple environments such as development, testing, staging, and production. Each environment requires different configurations. For example, in development you may use local MySQL database. In testing you may use in-memory HQL database. In production you may use a highly available Postgres cluster. Logging levels may differ between environments. Third-party service URLs may change. Managing all these configurations in a single application property quickly becomes difficult and error-prone. Spring Boot solves this problem using profiles. A profile allows an application to load environment-specific configurations and beans based on the currently active environment. So, what is a Spring Boot profile? A Spring profile is a mechanism for separating parts of your application configuration and making them available only in certain environments. Examples are dev profile, test, QA, staging, and prod. Only the configuration associated with the active profile will be loaded. You can think of the profiles as configuration layers. So why are profiles important? Without profiles, you have to configure it like Spring Data Source URL, Spring Data Source, username, password, and so on. The problems are developers accidentally deploy development settings. Production credentials may be exposed. Constant manual editing is required. Deployment becomes risky. But if you are using profiles, you can separate it out for dev, for test, for prod, different configurations in different files. Spring automatically loads the correct configuration. The advantages are cleaner configuration management, safer deployments, better maintainability, easier CI/CD integration, environmental isolation. Default configuration profile for every Spring Boot application it starts with application.properties. Example, you have server.port equal to 8080, Spring application name employment service. This contains properties and shared across all environments. Profile specific configuration files like if you have a development profile and you can define the specific configuration inside the development profile like server port 8080, 8081, data source URL, data source username, data source password. Logging level root equal to debug. You have a testing profile. You can define another server port 8082 and Spring data source URL as something else like testdb. Logging level root equal to info. You have a production profile, application properties. Inside that you can define some other server port and data source URL, data source username and password. Logging level equal to, you can define some other logging level. So how will you activate any specific profile? The method one, an application.properties file, you can mention that as spring.profiles.active equal to dev. You want to activate dev profile means you can equate that to dev. It loads, Spring Boot loads application.properties, application-dev.properties. So inside application.properties, because you mentioned it as active and active profile is dev, it loads the dev specific configuration. The second way of loading the dev profile is you can use Java jar command and you can mention the Spring profiles active as prod. This is extremely common in prod deployments. Third way is you can use JVM argument also like Java minus d spring.profiles.active prod, the jar equal to app.jar. You can use environmental variables also. In Windows, you can use environmental variable like set spring profiles active equal to prod. We use this kind of method like environment setting the environment variable in Docker and Kubernetes deployments. Configuring loading order. So how is the order? Suppose you have application.properties, you have application dev.properties, So we define the Spring active profile as Spring profiles active equal to Dave. Result is first it loads the server from the server starts, it loads the dev.properties. So profile specific properties override common properties. If you have given Spring profiles active equal to test, so this test profile will override the common properties. Priority is command line arguments. Next is environmental variables, profile specific properties and application properties. Using multiple profiles. You can use multiple profiles also, like Spring profiles active equal to Dave, Swagger. You can use it like that also using comma separated. Then it loads, Spring Boot loads application.properties, application Dave properties and application Swagger properties. Another way of loading is you can use profile annotation also. Inside the class, after the configuration annotation, you can mention the profile annotation and then inside that you can mention as Dave. This is also widely used. You can also use profile expression with uncondition, or condition, or not condition. How you can use it is inside that profile annotation, you can put prod and cloud. Bean loads only if both profiles are active. You can use or condition like Dave or test. Not condition also you can use. And another way is you can use profiles with YAML file. Instead of property file, you can use the YAML file, Spring name, and then you can use the name, give the name, development profile, production profile. Instead of .property file, you will have the property file, you will have the YAML files like application.yaml, application dev.yaml, application prod.yaml. You can view the active profiles by using system out println statement also, using array.toString, and inside that, before that you need to configure the auto void private environment variable. Using that environment.getActiveProfiles, you will get the output as whatever the active profile that you have configured. Example Dave. Next is Spring profile groups. What is profile group? Spring Boot supports profile grouping also. The profile group automatically it activates prod, monitoring and security. So what are the best practices for using these profiles? Keeps environment specific values in profile files. Never store secrets in sources control. Use environmental variables for credentials. Use profile annotation for bean selection. Keep profile names simple. Use profile groups in enterprise systems. Use production profile in deployment pipelines only. So how do you activate a profile? You can activate a profile using property file, command line, JVM augment and environmental variable. Another typical question is which configuration takes precedence. The priority order is command line arguments, environmental variables, profile configuration and default configuration. Someone asks you, can multiple profiles be active? Yes, multiple profiles can be active. Using comma separated, you can make multiple profiles active. What is the difference between Maven profiles and Spring profile? Maven profiles work during build time, Spring profiles work during runtime. So, in this session, we learned Spring profiles are one of the most important features in enterprise Spring Boot application. They allow developers to separate configuration by environment, activate environment specific beans, simplify deployments, improve security, support cloud native deployments. Almost every production Spring Boot application uses profiles extensively. If you understand profiles thoroughly, you already possess knowledge used daily by Spring Boot developers in real world projects. Next, we'll go to the next topic, logging in Spring Boot. Imagine an application running in production with thousands of users. Suddenly, users report that login is failing. API responses become slow. Database connections start timing out. Orders are being created twice. So, how do developers investigate these issues? The answer is logging. Logging is the process of recording information about what happens inside an application while it runs. Logs help developers debug issues, monitor application behavior, analyze failures, track user requests, audit transactions, measure performance, and so on. Without logging, troubleshooting a production application becomes almost impossible. So, what is logging? Logging is the practice of writing application events to a console, file, database, or external monitoring system. Examples of logs: application started successfully, database connection established, user logged in successfully, payment processing started. These are the different kinds of examples. Error logs: database connection failed, null pointer exception occurred, payment gateway timed out. These are the different kinds of error logs. So, logs provide visibility into the internal behavior of an application. Why logging is important? Suppose an API fails. Without logging, it shows 500 internal server error. So, the reaction of the developer is, what happened? Where did it fail? Which user triggered it? What input caused the issue? And so on. With proper logging, you'll see the error as payment failed for order so and so due to timeout. So developer comes to know what is the root cause of the error. The issue becomes immediately visible. The benefits of logging are faster debugging, easier troubleshooting, production monitoring, security auditing, performance analysis, and better visibility. What are the different logging frameworks in Java? Provided by Java, we have Java util logging. It's called Joule. So, but limitations are limited features, difficult configuration, and less flexible. We have Log4j, one of the earlier popular frameworks. Features are file logging, rolling files, multiple appenders, formatting support. Logback. This was created as the successor to Log4j. Advantages are faster, better performance, native SL4j, easier configuration. Spring Boot uses Logback by default. So if someone asks you what Spring Boot uses, it uses Logback by default. But you can configure other logging applications also. Okay? SLF4j, it stands for Simple Logging for Set for Java. It's not a logging framework, it's an abstraction layer. Think of it like you have like application code directs to SL4j and it directs to logback. This allows changing logging implementations without changing application code. Default logging in Spring Boot automatically configures SLF4j and logback. No additional dependencies are required. If you are using Spring Boot Starter Web, this starter includes logging support also. What is logger factory? It means a logger instance for the current class. The benefits are class name automatically appears in logs, easier debugging and easier filtering. Now let's discuss what are the different log levels. Logging frameworks classify messages by severity. Spring Boot supports 5 major log levels. 1. Trace. Its most detailed level used for method entry, method exit, variable values, internal execution flow. Examples are logger.trace. Inside that you will have some statement. Example output, it gives the output trace, employee service, and so on. Another level is debug. It's used during deployment and development. Example, logger.debug. You put the debug statement. It's useful for input values, SQL queries, and intermediate calculation. Next is info. Logger.info. This is most commonly used. It's used for application startup, request processing, and successful operation. Warning. War indicates a protection problem. Examples of logger.warn. Application won't stop, but application continues running. Next is error, used for failures. Logger.error. It represents serious issues requiring attention. The log level hierarchy is trace, debug, info, warn, and error. The application is configured for info. Enabled are info, warn, and error. Ignored are trace and debug. The configuring levels, how when you configure these logging levels? Default is logging level, root is info. Only info and above are printed. Now to enable debug for a specific package, logging level mention as debug, only classes inside that package show debug logs. You want to enable debug globally, logging.level.root equal to debug. If you mention this, it enables that globally. But you want to enable it at the specific package level, give that particular package like logging level company employee equal to debug. Extremely common in prod environments. Colorize logs. What are colorized logs? Spring Boot supports colors automatically. So for error it shows as in red, warning yellow, info as green. This improves readability in terminals. Logback configuration. What is logback configuration? It uses Spring Boot uses logback-spring.xml. It's located inside src main resources folder, and inside that you can configure it, root level info, and so on. What are appenders? Appenders define where logs are written. Examples: console, file, database, Kafka, and Elasticsearch. Profile-based logging. What is profile-based logging? In development, logging.level.root equal to debug. In production, logging.level.root equal to warn. Development needs detailed logs and production needs cleaner logs. This you can specify inside the application properties or application YAML file. What is the level that you want? Okay. So application for development profile, for dev profile, you can mention it as debug. For production level, you can mention it as warn. So in development, you get detailed logs. In production, you will get cleaner logs. Next, logging in cloud environments. How do you log in cloud environments? Cloud platforms, they collect logs centrally. There are various examples like ELK Stack, Grafana, Splunk, Datadog, and CloudWatch, Amazon CloudWatch. Now logs from all applications instances are aggregated into a single dashboard. So what are the common mistakes for logging is logging sensitive information. So never log sensitive information like passwords, credit card numbers, tokens, API keys, etc. Don't use system.out.println. Okay. Instead, you can use logger.info. So that's best practice are use info for business events, use debug for troubleshooting, use warn for suspicious behavior, use error for failures, never log secrets, use parameterized logging, store logs in files in production, use correlation IDs for microservices. The common questions are: which logging framework does Spring Boot use? Spring Boot uses SLF4J and Log4 Logback. What is SLF4J? SLF4J is a logging abstraction layer. Why do you want to use parameterized logging? It improves performance and readability. So how do you log exceptions? You can log exceptions using logger.error. Inside that you put the string comma exception. So let's summarize the logging. Logging is one of the most important aspects of enterprise application development. A well-designed logging strategy helps teams to debug problems faster, monitor applications effectively, improve observability, detect failures early, analyze application performance. Professional Spring Boot applications rely heavily on logging for maintenance and production support. Learning logging thoroughly will make you significantly more effective as a Spring Boot developer and prepare you for real-world enterprise projects. Next we'll go to the next topic: REST APIs in Spring Boot. So modern applications rarely exist in isolation. Example: a mobile banking application communicates with backend servers. An e-commerce website retrieves products from inventory services. A food delivery application talks to payment gateways and delivery services. The social media platform exchanges data between web application, mobile apps, and recommendation engines. So how do these systems communicate? The answer is APIs. Among the various types of API available today, REST APIs have become the industry standard for communication between applications. Spring Boot provides powerful support for building REST APIs quickly and efficiently. So what is an API? API stands for Application Programming Interface. An API acts as a bridge between two software systems. Consider a restaurant. You have the customer, waiter, and kitchen. Customer places an order. Waiter carries the request to the kitchen. The kitchen prepares the food. The waiter delivers the response. In software, you have the client application, which calls the API, which invokes the backend service. API acts as a waiter between clients and services. So what is REST? REST stands for Representational State Transfer. It's an architectural style introduced by Roy Fielding, author of the REST architectural style and co-author of HTTP specification. REST defines principles for designing scalable and maintainable web services. REST itself is not a protocol, library, or a framework. It's simply a set of architectural constraints. What is REST API? REST API is an API that follows REST principles and communicates using HTTP. What is a resource? Everything in REST revolves around resources. Examples: employee, product, order, customer, invoice, payment. Each resource has a unique URI. The resource represents a business entity. We typically think of REST architecture. The front end invokes the REST API. REST API invokes the business layer. Business layer calls the database. Example: the browser, you hit the employees, invokes the Spring Boot application. Application calls the database and returns the response. Why REST became so popular was before REST, many organizations use SOAP services. Why everybody started using REST is it's simpler, faster, lightweight, easy to understand, easier to integrate. The REST principles are client architecture. Client-server architecture, the client and server are independent. All communicate with same backend service. Benefits are independent deployment, independent development, and better scalability. REST APIs are stateless. Each request contains all information required for processing. Example request 1 login to user, request 2 server remembers user automatically. REST does not assume server memory. Instead, we use the authorization bearer token is sent with every request. So every request has to contain the authorization bearer token. Benefits are better scalability, easier load balancing and simplified deployments. Uniform interface. REST API should use predictable URLs like get/employee means it's a good example. It lists out all the employees. Post employee means you're creating a new employee. Deleting employees means delete employees. Consistency improves usability. Cacheable responses. Responses may be cached. It reduces server load. Layered system. Client do not know whether requests are processed by API gateway or load balancer or service mesh, microservice or database. This abstraction improves scalability. HTTP and REST. REST APIs rely heavily on HTTP. Common methods, HTTP methods are get, post, put, patch, delete. JSON and REST APIs. REST APIs commonly exchange data using JSON. JSON became popular because it's lightweight, human readable, language independent, easy to parse. Spring Boot automatically converts Java objects to JSON. XML support. Although JSON dominates modern API, XML is still supported. Spring Boot supports both JSON and XML serialization. Spring Boot REST architecture is typical flow is HTTP request to controller, to service layer, to repository layer, and to database. Response returned as JSON. Now let's go to the important annotation. 1. REST controller. REST controller tells Spring Boot return directly the data to the client. It's equivalent to controller and response body annotation. Without REST controller, Spring tries to return a view. Content negotiation. Clients can request different response formats. Suppose in the request header you accept application/JSON means accept only in the JSON format. Response will be in the JSON format. The request you say application/XML. Response will be in the form of XML. So both XML and JSON are supported by Spring Boot. HTTP status codes. You have REST API use status codes to communicate outcomes. We have different status codes as one example 200 request succeeded, 201 resource successfully created, 204 no content, 400 bad request, 401 unauthorized, 403 forbidden, 404 not found, and 500 internal server error. Versioning REST APIs. As applications evolve, APIs change. Versioning prevents breaking older clients. The header versioning can mention as X API version as 2 or 1 and so on. You can use that the query parameter also. So URI versioning is most common. What is idempotency? An operation is idempotent if executing in multiple times produce the same result. So example, you are deleting an employee. Deleting multiple times still results in employee does not exist. So get, put and delete are idempotent, but post is generally not idempotent. Pagination. Returning millions of records is inefficient, so that's why you use pagination. Benefits are reduced memory usage, faster responses and better user experience. So we have filtering. Filtering improves API flexibility. Sorting. Take use ATO stands for Hypermedia is the engine of application state. The clients discover available actions dynamically. So, what are the security considerations? REST API should implement authentication, authorization, HTTPS, input validation, and rate limiting. What are the different testing tools used by REST APIs? Commonly used tools are Postman, Insomnia, CURL, and Swagger UI. These tools simply result the developer with development and testing. Swagger documentation. Swagger automatically generates API documentation. Benefits are interactive testing, endpoint discovery, request examples, and response examples. Commonly asked questions are what's the difference between REST and SOAP? REST is lightweight and uses HTTP directly. SOAP uses XML messages and stricter standards. Which format is mostly commonly used in REST APIs is JSON. Which HTTP methods are idempotent? Get, put, and delete. Why is API versioning important? Prevents breaking existing clients when APIs evolve. So to summarize the REST APIs are the backbone of modern distributed systems and cloud-native applications. Spring Boot makes building REST APIs remarkably simple through annotations and auto-configuration. Strong understanding of REST principles helps developers create APIs that are scalable, maintainable, secure, easy to consume, and future-proof. Mastering REST APIs is one of the most important skills for any Spring Boot developer because nearly every enterprise application today exposes or consumes REST services. So that's all for this session. The next session we'll talk about controllers. What are the controllers? What are different types of annotation? What is a request mapping? What is controller advice? And so on. So if you like my videos, please subscribe and turn on the notification bell so you don't miss my next video. Thank you.